All right, good afternoon, everybody. It's so good to see you guys here. Thank you all so much for coming. How are you guys doing? Oh, fantastic, wonderful. Isn't this an absolutely amazing ship? It really is, it really is. It's wonderful to see all of you guys here. Yeah, thank you so much for coming. I'm Ed Macaulay. I'm a lecturer in physics and data science at Queen Mary University of London. Before that, I was actually an assistant professor of physics and astronomy at the University of North Georgia. And I know we have quite a few sailors here from the States. Now, it's great to see you guys here. And I have to say, I like you guys already because it's only day one of our cruise. And you guys are already thinking about your next vacation. So I think that's great. You're always thinking about the next thing, okay? Now, we're going to have plenty of time for some questions at the end of the session this afternoon. But if you do have any questions as we're going along, please do just let me know. Please do just ask if there's anything you'd like, anything you're curious about as we are going along. If you're anything like me, you always think of the question that you wished you'd asked kind of a few days later. Please feel free to just drop me an email. That's absolutely fine. And if you'd like to take any photos, make any recordings, that's absolutely fine as well. But just to give you guys a bit of reassurance, nothing that we're going to be covering this afternoon is going to be examinable. So I hope you can just relax and enjoy things a little bit. So it's wonderful to see everybody here. I have a research background in cosmology, and I've always been fascinated by space, even since I was very small. And I'm so excited to be here this afternoon to share with you guys and explore how space might be a destination that maybe one day we might be thinking about going on our next vacation. Now, I'd like to start with one of my favorite photos from a human space exploration. It's astronaut Buzz Aldrin. Now, Buzz Aldrin is most well known for being on the crew of Apollo 11, so the first human mission to set foot on the moon. But he's also, perhaps not quite so well known, for on a Gemini 12, he went on a spacewalk, and he took the world's first space selfie. This is the very first selfie taken in space. So I know it's quite easy to think, these days everybody's only just going anywhere and taking selfies of themselves. But don't despair, because Buzz Aldrin was doing this way back in 1966. So if you do want to take a selfie of yourself on the cruise, you are in very good company. Now, I have a question for you guys. How many of you guys would like to visit space if you had the opportunity? Okay, you guys both want. And what would you most like to experience if you visited space? Weightlessness, absolutely. I think that really would be quite an experience. How about you? Is that... the vision of it. Okay. Looking down at absolutely. So seeing this kind of view and being weightless. Would you guys be up for, as they say, extravehicular activity? Absolutely. You'd be up for it? Fantastic. Anybody else? Is there anything else that people would like to experience if they had the opportunity to go into space? So I think these are some of the big ones, right? That you get to experience weightlessness, so this sensation. Not having any gravity, and then also the absolutely extraordinary views. And I think that really would be an amazing thing to be able to, see the curvature of the Earth and see our home planet from that amazing perspective. Now, for most of human spaceflight, space has only been accessible to this very, very elite cohort of astronauts. But we're just starting to see now that space is just beginning to become a little bit more accessible. And I think that in the not too distant future, a trip to space really could be something that you might start to be actually thinking about, well, hey, maybe this is something we should give it a go. And that's really what we're going to be exploring this afternoon. Now, before we get to that, I'd just like to spend a bit of time thinking about, well, why is space so difficult to get to? So I've got a little satellite imagery here, and hopefully this should look fairly familiar if anybody has been looking at kind of, our voyage so far here. So this is, of course, the English Channel, and we've got the Isle of Wight, and we started in Portsmouth, just over there. I was very lucky, actually. I spent a few years, very happy years living in Portsmouth. Now, space, we often think of it as, very esoteric, very kind of otherworldly, but something which people often find surprising about space is it's not actually that far away. So if we actually look at, how far away is space? It's only about, kind of give or take, about this far, okay? So, you wouldn't even get as far as France, okay, if you were traveling into space. And the International Space Station, people go up there, they spend months at a time, but it's only really about as far away as Belgium, okay? So something which, might be a bit surprising is, why is space so much harder to visit than, let's say, France or Belgium, if it isn't that far away? We're going to look at some of the reasons why, and sometimes they might be a little bit surprising, because it's not really so much about distance. So as part of this, something I might want to think about is, where exactly does space begin? So I love this photo taken by Samantha Cristoforetti on the International Space Station. An absolutely beautiful photo of the Earth and the stars. And you can see Earth's very, very thin atmosphere here. Now, does anybody know where is the official boundary of, okay, this is where we're in space? Does anybody know? Has anybody heard a few things? Does anybody want to have a guess? How far do we have to go before we are in space? 100 kilometers. Excellent answer, okay. And that is, in a sense, the official boundary of, this is the boundary of space. It's 100 kilometers. Any other advances on 100 kilometers? How far away is space? Because this is actually quite an interesting question, and there's not exactly a unanimous answer. Any other advances on 100 kilometers? Okay, so 100 kilometers, it's a very nice kind of convenient round number, but the story is actually a little bit more interesting than this. Now, the thing is with space, there's no kind of hard and fast boundary, okay? It's just the atmosphere gets thinner and thinner and thinner. Now, if you're flying through the atmosphere in an aircraft, the higher and higher you go, you have to go faster and faster to still generate lift in that very thin atmosphere. And what a researcher called Kármán worked out in 1956 is that eventually, if you get as high as 83.8 kilometers, your aircraft would have to be flying so fast to generate lift with its wings that you would actually be in orbit. You'd actually just be falling around planet Earth. So your wings really wouldn't be doing anything. And he realized that that's at a height of 83.8 kilometers. So in a sense, if you're talking about like from a physics point of view, that's quite a sensible number to think about, okay, well, are we in space or not? But the plot gets a bit more interesting, because in miles, that's 52.1 miles. And this is where the story gets a bit muddled, because in America, they took the 52.1 miles and they said, well, we don't like that, let's just round it to 50 miles. So if you're in the USA, if you go higher than 50 miles, then you're officially in space. But for the rest of the world, the International Aviation Federation, they were looking at this 83.8 kilometers, and they said, well, let's us round that up to 100 kilometers. So depending on who you ask, where exactly does space begin, you might get potentially 3 different answers. So you may well get 100 kilometers, that is the internationally recognized boundary of space. If you're asking people based more in the USA, they might say 50 miles, or maybe if you ask a tedious physicist like myself, they might say something like 83.8 kilometers. Now, there's a few points that I'd like you to take away from this, okay? That the idea of like 50 miles, 100 kilometers, you may have thought all along that they're a bit suspiciously round numbers, and that's exactly correct. So, okay, it really is more like this 83.8 kilometers. The other point that I'd like you to take away is that none of these distances are particularly far, okay? 50 miles, you're talking about like an hour's drive, okay? So space is not really very far away. And that's just because our atmosphere, this precious thing that keeps us alive, it is so extraordinarily thin. The last thing that I'd like you to kind of bear in mind, as well as all these numbers are kind of a bit different, is that no particular one of these numbers is a kind of particularly magic sort of special number. If it's 50 miles or 100 kilometers or 70 miles, the point is somewhere about that kind of height is roughly where there's really not much atmosphere, and you might fairly say, okay, we're now in space. So when we're talking about space tourism, people do often get a bit hung up on this, is it 50 miles or 100 kilometers? But from a kind of physics point of view, what matters a bit more is, are we in just space or are we fully in orbit? Now, can I just get a sense here, how many of you guys are kind of familiar with this idea of, okay, we're being in orbit, and now this is a bit different to just being in space? Okay, so let's take a look at this idea in a bit more detail here. So I've got this beautiful blue picture. This is a kind of updated version of the beautiful blue marble of our home planet Earth. This is just a photograph, and it really is absolutely beautiful. Now, some of the very first missions into space, and the first American astronaut, Alan Shepard, he went on what's called a sub-orbital spaceflight. So this is when you go in a rocket and you go just above the atmosphere of the Earth, and then you come back down again. Okay? So the whole thing maybe might take about 10 or 15 minutes. So you're in space, you're above the atmosphere, you get kind of 10, 15 minutes of weightlessness, and you get those amazing views. So you get the full astronaut experience. But you don't stay in space. Now, if you want to stay in space, sometimes people think, well, maybe you just got to go a bit higher. You've got to go further away from the Earth. But the answer of how you actually stay in space, when I first found about it, it's actually quite surprising, because it's not about going high, it's about going fast. So let's imagine we get to the top of our suborbital space mission. And instead of trying to keep on going up and up and up, we instead try and go sideways as fast as we can. Let's see what's going to happen. So suppose we fire some extra rockets, we go sideways. As we're going sideways, the Earth is actually curving away from us. And we're actually going to take a little bit more time before we come back to Earth. We're going to have a bit more time to enjoy the view, a bit more time in weightlessness. Now, if we go even faster, you might be able to guess what happens, okay? So if we go even faster, the Earth curves away from us even more, and we spend even more time in weightlessness. Now, if we go even faster still, the Earth is always falling away from us as fast as we're falling towards it. So we're always falling towards the walls of our spacecraft, but our spacecraft is always falling towards Earth, and we just keep on going in this orbit here, and that is what being in orbit is. So being in orbit, it's not about being very high or very far away from Earth. It's about traveling so fast that you're always falling away from it. So when you see those amazing photos and videos of astronauts in the International Space Station, gravity for them, it's actually not much weaker than it is just on the surface of the Earth. But the difference is they're traveling really fast, and they're always falling around Earth in an orbit. Now, the thing is, to get to an orbit and to stay in orbit, you have to be traveling unbelievably fast. Okay? So let's take a look at just how fast you need to be traveling to stay in orbit. Now, the fastest that you might kind of reasonably think, if on a kind of any kind of human speed scale, maybe is if we think about Concorde. Has anybody here ever been on Concorde? Did anybody here ever get the opportunity? So I was very fortunate. I did amazingly, while it was still flying, get the opportunity to fly on Concorde, and it is an absolutely incredible aircraft, because you're flying twice as high as a conventional airliner. And if you look out the window, you really can see the curvature of the Earth. So, to have had the chance to see the curvature of the Earth with my own eyes is really amazing. And if you look up, the sky's not blue, it's actually kind of black, because you really are above so much of the atmosphere. Now, Concorde, very, very fast jetliner, flew at twice the speed of sound. Okay? Now, if you want to stay in orbit, you have to get your spacecraft above the atmosphere of the Earth. So you have to go about 100 kilometers above the atmosphere at least. That's the easy part. If you want to stay in space, you need to be traveling really, really fast. Okay, so to be in orbit, you need to be traveling 10 times faster than Concorde. Okay, so Concorde traveling twice the speed of sound. So to go into orbit, you need to be traveling so much faster than that like you'd hardly notice the speed of Concorde. You know, Concorde just be kind of chugging along there, okay? And bear in mind, this is, you know, the fastest jetliner that was ever made. Now, question, has anybody here studied any physics or any engineering, anything like that? Okay, a couple of people. So maybe this question for you. Suppose our speed is going to be 10 times faster than Concorde. How much more energy are we going to need? Does anybody want to have a guess how much more energy we're going to need? 100 times. Who said that? Fantastic. You've got it. You can definitely stay. Fantastic. Brilliant. So if we want to be traveling 10 times faster than Concorde, we need 100 times more energy. Okay? So it's not like a 10 times more difficult problem. It's 100 times more difficult. So all that heat, all that stuff, everything's melting. It's 100 times worse. Okay? Now, last question for you guys. If we're traveling 100 times faster, does anybody want to take a guess how much more expensive that's going to be? Does anybody want to take a guess to go 100 times faster? You're getting warmer. So to go 10 times faster, we've got to take that 10, and it's actually 10 squared. That gets us to 100. So energy is about proportional to speed squared. Cost, again, this isn't kind of physics, but it goes roughly as about kind of energy squared. So if you want to go 100 times faster, it's going to cost you about 10,000 times more. Okay? And bear in mind, this is 10,000 times more than Concorde, okay, which was not renowned for being a particularly affordable form of aviation. Okay? So if you think about how much a ticket on Concorde costed, if you know, you wanted to say, okay, I want my next vacation to be in orbit, you're going to have to go 10 times as fast, you're going to need 100 times as much energy, and that's going to cost you about 10,000 times more, okay? So it really is a whole different ball game, okay? And this is why, you know, even compared to Concorde, you know, there's still only ever been, you know, a few hundreds of people who have made it into orbit, because it really is a stupendously difficult problem, okay? You need so much more energy, and it just ends up being so much more expensive. But what is so exciting, and what I really like to explore with you guys this afternoon, is that in the past few years, there have been some absolutely really exciting developments, which are really starting to change this status quo of how we can access space and how we can make it affordable. And I'm so excited to be kind of exploring some of these ideas with you guys. Now, until, you know, really very, very recently, that was kind of the only way to get into space. You just had to pay a huge amount of money. Does anybody know who this guy is on the right here? Does anybody recognize him? So this is actually Dennis Tito, and he is the very first space tourist, okay? So he was the very first guy who went to space as a vacation. So he took a Soyuz capsule up to the International Space Station. But he really went very much in the same way as astronauts have been going since the start of human spaceflight. So he paid about $20 million for this vacation, okay? So if you think your executive luxury room is expensive, just spare a thought for Dennis Tito spending $20 million on his vacation, though. In fairness, he did like it so much that he went up again, okay? So clearly he thought he was getting a good deal there. But of course, spending $20 million just on a couple of weeks in the International Space Station, that's not going to be for everyone, okay? But you know, he was the first, and he did show that, you know, you can pay and you can kind of go on and go and explore space, you know, as a tourist. So Dennis Tito went to space in one of these Soyuz capsules, which has really not changed very much in almost all of human space exploration. So it's actually a very small, very claustrophobic capsule. This is the only part that comes back to Earth here. But this is an absolutely beautiful photo of a Soyuz capsule docked at the International Space Station. So for about the past, you know, 20 years or so, if you wanted to, and you had a spare $20, $30 million, you could buy yourself a seat on a Soyuz capsule, and you could spend a couple of weeks in the International Space Station, and you could experience weightlessness, you could experience these amazing views of the Earth. So Dennis Tito was the first, but there have been a few other kind of very interesting other examples of kind of exploring space like that since then. So a few years ago, back when I was kind of finishing grad school, I was at a conference in Texas, an astrophysics conference, and the conference reception was actually hosted by this guy over here, Richard Garriott, who was another space tourist. So he had a very successful career developing computer games, and then he followed in his footsteps as a space tourist. So again, he went and spent some time on the International Space Station. And what I think is so interesting about Richard Garriott is that his dad was also an astronaut. So his dad was Owen Garriott, was one of the Skylab astronauts. So Richard Garriott is the first second-generation American astronaut. So the first American astronaut whose parent has also been an astronaut. And he now keeps his Soyuz spacesuit in his home on display, which is pretty cool. It's not something kind of most people can have on display. But of course, if you go on to the International Space Station, that's a kind of really nice souvenir to have. So in a way, this first phase of space tourism, it really was very much just kind of following what kind of traditional astronauts do, just paying a lot of money for it, okay? So it's very exciting, and I think it's very cool that space tourism got started like this, but it's not going to be something for everyone. So what I'd like to think about now are some of these really exciting developments that have just been starting to happen over the past few years, which are really starting to make space more accessible, and they're starting to make a trip to space something that, I think conceivably might be something that, some of us might kind of actually starting to think about, okay? And I think a real landmark moment was this back in 2004. This was SpaceShipOne. Has anybody seen SpaceShipOne before? Okay, so it's slightly more than 20 years ago. And it was a really very radical, innovative design for a spacecraft. And it won what was called the X Prize, which was a prize given to the first privately developed spacecraft to travel above that 100 kilometers, and had to travel above it twice, okay, in order to win the prize. So it had to be a kind of reusable spacecraft. So it was flown by Mike Melville, who became the first astronaut to fly a fully privately developed spacecraft above that 100 kilometers. And it was a very innovative design. So it launched from a carrier aircraft that dropped it, and then it flew up, okay? Now, this wasn't an orbital mission, okay? This is a sub-orbital mission. So you go above the Kármán line, you go above almost all of the atmosphere, you get those amazing views of space, you get the zero G, you get the weightlessness. Things you only get to stay up there for kind of 10, 15 minutes, okay? You're not going to be staying in orbit indefinitely. But after this SpaceShipOne won the X Prize, and it shows that you can privately develop something that goes into suborbital space. This caught the attention of a certain businessman who I think you probably would be familiar with, Richard Branson, okay? Because he saw the potential in this. He saw that, if you can send a spacecraft in suborbital space, maybe that's something that you could use to take passengers on trips to orbit. So he founded this Virgin Galactic here, okay? And they developed a new spacecraft very much based on this SpaceShipOne, to the same kind of idea. So it flies up in this, this is the carrier aircraft, and this is the actual spacecraft underneath it, drops down, and that's what goes up into space. It's slightly bigger than SpaceShipOne, and it can take about 6 people into space. Okay, so it goes into suborbital space, and it's way, way cheaper. Actually, cheaper is not the right word at all. Let's just say it's less money than going into orbital space. Okay, I think it's still not fair to say it's cheap, but it really is just far, far less money than that. Think about like $20 million or something to go to the International Space Station. And they have actually sold tickets, and they have taken private space tourists into space on this. So it really is fantastically exciting, okay? So this is the actual spacecraft here. This is the part that goes into space, and they've built these really beautiful panoramic windows here, so real circular windows, so you get a really amazing view of the Earth. And they're currently doing some more development on this spacecraft and planning to kind of go with the next phase of this pretty soon. But they have been selling tickets. They have been taking people into space, and I just think it's extraordinary to be living in a world where you can pay some money and you can go up into space and become an astronaut. So that image I had at the beginning was actually taken from one of the flights with Virgin Galactic. Okay, so it's taken from the Unity 25 flight. And you can see you get these extraordinary views of Earth. You're all above the atmosphere. Outside it's just black. You're experiencing that microgravity. You experience that weightlessness. So it really is giving you that full experience of being an astronaut. Now, the exact costs for this, I think it is not too easy to find, but I think kind of ballpark something like in the kind of hundreds of thousands of dollars, maybe like kind of $500,000. So it's still a lot of money, okay? But it's much, much less than like $20, $30 million, okay? And it's starting to get into the kind of ballpark where some people might think, okay, maybe this is something we might kind of think about as a kind of once in a lifetime kind of special experience. And my hope is that, as they progress, as this kind of develops, it's going to be something which is going to become more affordable and more accessible. Now, I'm well aware that at the moment, we are on Virgin Voyages, and, Virgin Galactic is very much on brand. But it would be remiss of me not to mention that there are other suborbital space options available. Okay, I think it wouldn't be complete to leave this out. Okay, so you may also have heard of Blue Origin. How many of you guys heard of Blue Origin before? Okay, yeah, you guys. So this is a space company led by Jeff Bezos, of course, of Amazon fame. And they're also planning a big orbital rocket, but they also have this smaller rocket, the New Shepard rocket, to take people on suborbital flights. So in a sense, it follows that same kind of mission profile as the Virgin Galactic. So you go up above the atmosphere, you kind of go above almost all of the air in the atmosphere. You get about kind of 10 minutes of weightlessness, and you can see the curvature of the Earth and the blackness of space. But they've taken a very different approach to it. So instead of taking off under an aeroplane, it blasts off with a rocket. So this part here is the rocket. And then this top part there, that is the capsule. So that's where the 6 astronauts are. And that returns to Earth under a parachute. And then the rocket lands, and it uses its own rocket to bring itself into a soft landing. So something that's very cool about both of these, so they both have 2 parts, either a rocket or a capsule or a plane and that kind of space shuttle kind of part. They're both fully reusable. And this is a big part in making space more affordable, okay? Because if you're throwing your space rocket away every time, clearly that's going to cost a lot of money, okay? So just for a bit of comparison there, your typical space rocket, okay, it might cost about as much as a big cruise ship, okay? But imagine if you made a big cruise ship and you said, okay, I'm only going to take 4 passengers, and after each voyage, we're going to throw away the whole ship. We're going to have to build a new cruise ship, okay? Clearly, that's going to make cruising a lot more expensive, okay? That's not going to be something that everybody can do. But if you can make a cruise ship and take, thousands of sailors, and then you can, have it running for, 20, 30 years, it becomes much more accessible. And my hope is that human space exploration is going to be moving in that same direction as well. So, we now have a fully reusable space system here. And at the moment, they can take 7 astronauts. So it's probably going to cost in a similar kind of ballpark as the Virgin Galactic, okay? So it's definitely not a kind of everyday kind of occurrence, but it's beginning to become into the kind of realm of the thing that, maybe some people might be able to think about as a kind of once in a lifetime experience. And my hope is that from here, it's going to become even more accessible, because the views are just absolutely stunning. Don't you think that's just absolutely jaw-dropping? This is not CGI or an artist's representation. This is just a photograph taken from inside the capsule. I mean, this almost looks like something out of Star Wars, right? But it's just planet Earth. This is our home planet, and the beautiful blue of the atmosphere and the blackness of space, and you're in microgravity. I mean, how extraordinary would that be, right? So already, people have been able to get this experience. My hope is, in the next few years, this really might be something that more and more people would get to experience. Because I think it's just stunning. I mean, I can just look all the beautiful colors in the planet just all day there. Okay. Now, as with the suborbital things, really one of the big keys to making space more accessible is not throwing away your whole space rocket every time, okay? And a big landmark moment in this was in 2015 with SpaceX, okay? And they landed the first stage of their rocket booster. So this is a bigger rocket booster that actually puts things into orbit. So it goes above the atmosphere, and then it can also go more than 10 times faster than Concorde to keep things in orbit, okay? Now, it's not fully reusable. They don't reuse the second stage of their rocket, but the biggest stage, the big first stage, they now reuse it, okay? And they launch these rockets every few days, and they come back to Earth, and it never ceases to amaze me. They always land right on the target here. Has anybody seen a SpaceX rocket launch or a rocket launch? Oh, wow. Where did you guys see the launch? Oh, you saw one. You saw in Texas. Wow. Did the big one? Wow. Okay. I might have to come back to you about that. That's awesome. Wow. And who's seen any other launches? Yeah. Which launches have you seen? Florida. So was that a Falcon 9? Yeah. And did you see the landing as well? Okay. So it was landing back in Florida. Wow. Honestly, I would just love to see one land. I think that's absolutely extraordinary. So this is a huge kind of quantum leap in making space more accessible, okay? Because if you can bring your spacecraft back, then clearly that's going to make life easier for everybody, okay? Now, another big landmark moment came a few years later in 2021 with Inspiration 4, okay? So this was a private space mission on the Falcon 9 space rocket, okay? But what was so amazing about this mission is that all of these crew of the mission, they were all private astronauts, and for all of them, this was their first trip into space. Could you imagine going into space? And no one has been into space before, okay? So the mission was led by Jack Eisenman over here, okay? Who is, a massive aviation enthusiast. So he flies all kinds of private jets and things. And he's really now a very kind of eminent private astronaut. But he really led this very pioneering mission into Earth's orbit, okay? And then he took this other extraordinary crew of astronauts with him. The reason I think this is such an exciting mission is because all of these people here were all private astronauts, and it was their first time in space. And it was a resounding success. It really was an extraordinary mission, okay? They all, made it to orbit. They, achieved all their objectives. They all came back safely. Okay, so it proved that it could be done. Now, this is still going to be very, very expensive. Okay, we're talking in the tens of millions of dollars. So, if you're a billionaire, that's all well and good, but it's still not a kind of something that's going to be accessible to a lot of people. Now, clearly, Jack Eisenman, he liked this so much that not long after this, he actually went on another mission, the Polaris Dawn mission, and he undertook the first private, as they say, extravehicular activity, okay, the spacewalk. So this was the first time a private astronaut went on a spacewalk. I don't think he took a selfie of himself, unlike Buzz Aldrin. Maybe that was a bit of a missed opportunity. But, he really is kind of making kind of pioneering steps in private human space exploration. So this was the launch of Inspiration 4, which launched from Florida. So it's a time-lapse photo. I think it's an absolutely beautiful photo. As well as just being a really beautiful photo, something that I like about this is it really shows what's going on with getting into orbit. Because when you see a rocket launch on TV or anything, you see this first part here, you see the rocket going up, and it looks like it's just going up and kind of punching its way into space. But if you keep looking, you can see it actually kind of doesn't just keep going up forever. It reaches its kind of maximum height there. And then from this perspective, it looks like it's falling back over the horizon. And really that's kind of exactly what it's doing because it's entering orbit there. So it's above the atmosphere and it's now going in this orbit here, and you can kind of follow it all the way there. So once they get to the top there and they're falling over, that's where they're going to be in that zero gravity in the weightlessness there. Now, after Inspiration 4, there have been several other private space missions in a Falcon 9 booster here. I think this Axiom Mission 1 is especially exciting. So this is the Dragon capsule here. So they flew and they docked with the International Space Station. So this is the first all-private mission to dock with the International Space Station. So, you know, in less than 20 years, we've gone from one person taking one seat on a capsule to the International Space Station to a whole mission where everyone is there on a private basis and the whole mission is flying to take these private astronauts to the International Space Station. So there really is kind of very exciting progress. And this photo was taken from the International Space Station. And again, I just think it's absolutely jaw-dropping. You know, it's not CGI, it's not from a movie. You know, you've got the moon in the background there and the Earth and this capsule coming up towards the International Space Station. So I think it must be so unbelievably exciting. I mean, can you imagine what it must be like to be in this capsule and, you know, see the International Space Station and think, okay, you know, this is where we're going to be spending our next couple of weeks on vacation. Now, who was in Texas? Is this the rocket you saw launched in Texas? Did you see the first part of it launch? Oh, wow, that is really very cool. Okay, because I think in a way the next kind of phase of human space exploration, and really something that could open up the doors of space tourism, it's really going on right in Texas with this SpaceX Starship project. Okay, so this is an absolutely enormous rocket which is currently being built, and they're doing test flights out of Texas. And there's a couple of really exciting things about this. Okay, so this is by far the most powerful rocket which has ever been made. Okay, so it's more powerful than the mighty Saturn V rocket which put humans on the moon. The other super exciting thing about it is the whole rocket is designed to be reusable. So this is the first stage of the rocket, the Superheavy booster, and this second part with the little fins on it, that is called, they call it Starship. Okay, but both parts are designed to be fully reusable. And the way it comes back, it just sounds totally nuts, but they're kind of making it work, right? So they've already successfully brought this massive booster down. Have you guys seen this? How many of you guys seen this even on videos, right? They actually catch it. I'm not making this up. They've called this thing Mechazilla, okay? So I think that kind of gives you some idea. And then these things, they call them the chopsticks. So they catch this absolutely enormous rocket. You know, this thing is coming back down. It's only just slowed down slower than the speed of sound, and it fires this rocket just at the last minute to bring it to slow down enough. And then this kind of Mechazilla thing comes and grabs it. It sounds totally nuts. It sounds like it's kind of made up, but they're actually making it work, okay? And the reason that this is so exciting is because it offers the potential to fully reuse your whole space rocket. So not just reusing the booster and throwing away the second stage. You can potentially reuse the whole thing. So in principle, you could bring down the cost of putting things into orbit. You're really kind of getting down to the cost of putting the fuel in. You know, that's going to be the one thing that you won't be able to get away from. The other thing is this rocket is absolutely enormous. Okay, you could maybe think about putting something like 100 people into orbit with each of these. So it really could be something which gives people the potential to, you know, go into orbit, you know, for maybe kind of the cost of currently going into a kind of sub-orbital thing. And, you know, on there, you know, this rocket is designed to take humans not just to the moon, but onwards to Mars. Okay, so it really is opening up a kind of new chapter in human space exploration. So it's not even the situation where, okay, if you pay $50 million, you can go to the International Space Station. This really is changing the status quo. And a big part of it is because the thing is going to be fully reusable. Now, you can't right now book yourself a ticket on Starship. If anybody does try and tell you a ticket on Starship right now, I would say hang on a little bit. It does have a tendency, it does explode quite a bit. I would not recommend anybody going on it just yet, okay? But what I would like to think about a little bit now is how you can get a bit of a taste of what it's like to be an astronaut. So some of these things we've talked about, maybe that sensation of weightlessness, or maybe some of these extraordinary views, without necessarily traveling all the way into orbit. Just before we get to that, there's this quite exciting project by Axiom Space. So these are the same guys that sent that Axiom Mission onto the International Space Station. They're actually planning to develop a whole space station that they can then send their private astronauts up to. So the International Space Station, very sadly, is not going to be around forever, but there are already plans for something which could be a successor to it, so you could have another destination in orbit. Now, what do we think is going on in this photo over here? Okay, so it looks like we've got a bunch of astronauts, and we've got everybody floating around here. We've got some experiments going on here. Maybe it looks like it could have been taken in a space station or something like this. Does anybody know what is going on in this photo, or where this photo was taken? Yeah, where's this photo? Do you know? Exactly. So this photo is actually taken in an aircraft, and it's going on what's called a parabolic flight. Has anybody heard of this before? Okay, you guys heard this before. Would you guys go on a parabolic flight if you could? Absolutely, absolutely. Brilliant. So what's going on here? This is actually, even though it kind of looks like maybe it could be in a space station, this is actually a kind of refitted interior of what's otherwise a fairly conventional jetliner. So this example here from the European Space Agency is an Airbus A300. And it flies in what's called a parabola. So it flies in the path that something would take if you threw it. Okay? So if you imagine taking like a football and you throw it and it travels in a parabola, this aircraft travels in that exact same path. Okay? So if we take a look inside, so they've put kind of safety padding and stuff, and they block out the windows, that can be a bit disorientating. And the amazing thing about flying in a parabola is that you're still falling towards the Earth, you're still being pulled by gravity, but the spacecraft is falling to Earth in exactly the same way. So it's kind of just floating all around you, okay? Now this is, remember, exactly what's going on in the International Space Station. So sometimes people say this is like a simulation of zero gravity, or like an approximation. It's not, it's exactly the same feeling as being in zero gravity on the International Space Station. One of the differences, though, because you're flying in an aircraft, you can't stay in this parabola forever, okay? You're going to want to pull out of that parabola, otherwise things are going to end very badly for you. So you get something like 30 to 40 seconds of weightlessness at a time. But you don't just get one, you can go on a series of parabolas, okay? So if you go on a flight in a parabolic aircraft, you can actually clock up more time in zero gravity than some of the first Mercury 7 astronauts, okay? So some of these kind of, absolute legends of human space exploration, you can go on a parabolic flight and you can get more zero gravity time than them, okay? So this is the European Airbus A300. But there's also a similar company in Florida, and this was how Stephen Hawking got an experience of zero gravity. Did anybody see this when Stephen Hawking went on zero? It was absolutely beautiful. I mean, just kind of love the expression there, right? So, it really is something which can make this sensation of zero gravity kind of a lot more accessible. Now, I certainly still wouldn't say this is a kind of cheap experience, but it costs like in the region of kind of the thousands of dollars, okay? So it is kind of the sort of thing that, maybe if you're thinking about, should we go on a cruise or maybe a kind of parabolic flight, I guess it's kind of similar sort of ballpark, okay? So it is something which is making one of those key things of being an astronaut, that sensation of zero gravity, a lot more accessible. So it's something you could give a go if you're feeling adventurous. Now this is giving you the exact zero gravity sensation as on the International Space Station. There's other options, though, other things you might want to think about here. Has anybody seen something like this? They call it indoor skydiving. Has anybody tried indoor skydiving? What did you guys think of it? It's awesome. It's awesome. Where did you guys try it? In Vegas. Cool. See, I kind of think in a few years' time, so at the moment, you go to Vegas to try indoor skydiving. I think in a few years' time, you're going to go to Vegas, and maybe for like the high rollers, they're going to send them on a suborbital flight. I think that's how it's going to go, okay? Has anybody else tried indoor skydiving? Where did you try it? Denver. What did you think of it? It was cool. Okay. So I love it. I gave this a go. For me, it was the kind of thing like, I'm glad I tried it. Once was enough for me. I got to be honest with you. Okay. Now, this is not the same sensation as being on a parabolic flight yet, because you're not actually in free fall. Okay. Essentially, you're being suspended, but you're just by air. So kind of dynamically, it doesn't feel like you're in free fall. But it still does give you a very kind of cool experience and a lot of that kind of sensation that you might imagine being on the International Space Station. Now, if you don't fancy doing indoor skydiving, there's still other ways that you can kind of get a sense of that kind of floating freely experience, which must be so great if you're an astronaut. And it's something that NASA themselves use. Okay, so for their astronaut training, they use this kind of neutral buoyancy tank. So it's an enormous swimming pool, and they have parts of the International Space Station there, and the Hubble Space Telescope if they're practicing servicing, and they lower their astronauts in their spacesuits in there. And the reason is because being underwater, being in that neutral buoyancy, it's this kind of similar experience to being in zero gravity there. And that's something that you can experience if you want to. You can go scuba diving. How many of you guys have gone scuba diving? Where did you go scuba diving?
Around the coast of the UK we went, but it was really murky.
Okay, really murky. That's brave you going in the UK. Like that's too cold for it. Too cold for it.
Really murky, not enjoyable. So we said gone down.
But did you at least enjoy like the neutral buoyancy side of things?
Absolutely. I mean, we did a lot of training in the pool before.
Okay.
So I was quite used to that, and it was brilliant.
Fantastic.
But yeah, when we got to open sea, it was like, yeah.
Bit too murky. Brilliant. Has anybody else given scuba diving a go? Where did you go scuba diving?
Everywhere.
Oh, okay. Yeah. I got. If you are thinking about going scuba diving, I got it probably the UK. Wouldn't say top destination, but if you do get a chance, because you do experience that kind of neutral buoyancy, and it really is authentically something that is used in training astronauts. Okay, so that's another way you can kind of explore and get just a bit of a taste of what it is like to be an astronaut. Now, there's another big side of things that I think some people mentioned at the start. Okay, so one of the amazing things about being an astronaut is, of course, the extraordinary views. Okay. So this was a view taken from a SpaceX capsule at the International Space Station by Don Petit. He takes absolutely extraordinary photos. Okay, do check them out. And you can just see this absolutely beautiful, beautiful Milky Way. And again, I think if you are in the International Space Station and an astronaut, I think those views they just seem absolutely extraordinary. And the photos are amazing. But I think to be seeing them with your own eyes must be just something else entirely. One of the things that I hope you guys take away with you, though, is you can get these extraordinary views right here from planet Earth. Okay, so this is an absolutely beautiful view of the Milky Way. It's taken from ground level. Okay, now this is not a photoshopped picture. Okay, this is just a long exposure photo. And aside from the kind of depth of the colors, this is really what a kind of very dark night looks like. Okay, have any of you guys been stargazing or seen the Milky Way on a very dark night? Where did you guys go? Northern Scotland. Okay, that's going to be dark, going to be cold.
Yes.
So, could you see much of the Milky Way from there? Okay, see a bit of the bands there, and it really is beautiful. If you do, so I was very lucky because I spent a few years living in Australia, and they have amazing dark skies there, and the Milky Way, because you're looking into the centre of it, it's just utterly stunning. It's just this massive thing that goes all the way across the sky. Now, I guess, did you guys, there's not quite this much colour, right, if you're seeing it. Yeah, you only really see the colour in long exposure photographs, but you do see this enormous expanse of the Milky Way. And if you get to a really good kind of dark site, the stars, they just kind of like glisten like these kind of big fat diamonds in the sky. It really is absolutely stunning. And these are exactly the same stars that astronauts are enjoying, okay? So don't forget that a lot of the things, astronauts find most amazing, we got them here right here on Earth, okay? So even when the astronauts were training for the Apollo missions, they actually went to Arizona as part of their training. So this is James Irwin and David Scott training for Apollo 15. So in a way, it looks like they're kind of playing dress up for astronauts, but they're actually kind of serious rehearsals here, because we have such an extraordinary variety of terrain on planet Earth. So, you know, if you're even thinking about, you know, exploring the moon, you can find some terrain which is going to be good to practice that. Has anybody been to Arizona, seen the Grand Canyon? This is a major thing on my to-dos. When did you guys go to? Oh, you live in, oh, fantastic. Okay, fantastic. I love it. I have not been to the Grand Canyon yet. It is a major thing on my to-do list, okay? But I mean, the views are just absolutely stunning. And maybe if you were a kind of location scout for a sci-fi movie, maybe this could be Mars or something. I guess the running water is a bit of a dead giveaway. But the point is, we really do have these extraordinary vistas on Earth, and in some sense, they are quite similar to things that astronauts might be exploring themselves on the moon, or maybe one day on the Mars. And I think that's one of these wonderful things about going on a voyage like this, because you know you do get to explore so many extraordinary places, and I hope you know it really helps to take it all in. And I think in a way, that's one of the most important things that we actually get from studying space, because you might think, okay, we're studying the stars and the galaxies and the black holes. But one of the things that I think is so important is that it gives us a new perspective on our own planet. So this is an absolutely famous photo, a real landmark photo in space exploration, the famous Earthrise photo taken by Bill Anders on Apollo 8. So Apollo 8 was the first human mission to send humans beyond the Earth's orbit and around the moon. They didn't land on the moon, but it was an extraordinarily ambitious mission. Who has seen this photo before? Absolutely beautiful photo, I think. So this photo is the moment, this is the first moment that humans saw Earth rising over another celestial body with their own eyes. So it's the first time that we've really seen Earth, not as like, you know, this kind of slab of rock and water that we all live on, but as a planet in space, okay? And it really does kind of give you a new perspective on there. So when astronauts come back from space, they often talk about what they call this overview effect, that, you know, seeing planet Earth like this, it really does give you a different perspective on Earth and all of the life we have. Now, you know, I've not been into space, but I have spent my career studying space, and I think the more we explore space, the more you appreciate this perspective, and I think it really is an important thing, and it's one of the reasons why I'm so excited about the prospect of more humans going into space, because I think when people come back from space, they don't come back quite the same as when they went, and I think that's one of the reasons why it's so important. So there's all kind of amazing views from space, and I think certainly if I went up to space the first time, I'd probably spend the whole time just looking out the window, but I always think it's quite amusing to see how astronauts actually do spend their time. So when Star Wars came out, they actually organized a bit of a movie night right up there on the International Space Station. And there's something about my sense of humor that just finds it amusing about having genuine astronauts being in space, spending their time essentially watching pretend astronauts for entertainment. But I think it makes the point that everybody loves a good science fiction movie. And I know, you know, for myself and quite a lot of my colleagues who've, you know, gone on to study space, you know, watching science fiction movies and being inspired by that, you know, it's one of the main ways that you might kind of really think about, you know, space and see a lot of images of space. And there can be a lot of really good science in there, okay? So this is a little bit of a heads up about next time, actually, okay? Because next time we're going to be back here, we're going to be thinking about some of the science of putting space on screen. We're going to be thinking about some really cool, some of my absolute favorite kind of NASA-themed movies, and we're going to be looking at maybe some of the times they took a few liberties with the science, maybe some things they didn't get exactly right, but overwhelmingly some of the amazing stuff that they actually did get right. And why it's so important, because I think it really does help to inspire new generations about space and think about exploring space by themselves. So if you've enjoyed this, I really hope you can kind of come back in a couple of days. We're going to be back here and thinking a little bit about space on screen, okay? So we're going to have a little bit of time for questions right now, but please do feel free to, you know, drop me an email if you've got any questions, or, you know, if you see me on board. I always love chatting about, you can probably tell, always very happy to chat about this stuff. So if you see me around and you've got a question or you just want to chat, that's absolutely great. I'm very happy to chat all day. And actually, I'd like to chat with some of you guys about all the cool stuff you've been doing. So we will have a bit of time for questions. I think we do have to wrap up in a couple of minutes. But I just want to say, your questions have been absolutely fantastic. I've loved hearing about all of the cool stuff that you guys have already been doing, okay? So I hope you guys have an absolutely fantastic time here on this ship, okay? I hope you're really excited about the kind of destination and, you know, in this spirit, kind of exploring some really new places, okay? But for now, I just want to say thank you so much for your questions, and thank you all so much for listening. Thank you.